Hey y'all, thanks for coming to see me and welcome to CICD Through the Ages. First, a little bit about myself. My name is Kat Cosgrove and that is Espresso. I am a staff developer advocate at Pulumi. And I didn't get where I am through like strictly traditional means. I was a freelance web developer for a few years, and then I was an embedded Linux engineer, but I've also been a bartender, a waiter, a teacher, and the resident horror expert at an independent video store. So if you want to ask me questions about that, that's fine too. And I credit a lot of what I do and how I am as an engineer and as a developer advocate to the fact that I didn't get here through like strictly traditional means. It has allowed me to have a lot of different struggles and see the tech industry from a lot of different angles. And some of those struggles are pretty universal, it turns out, regardless of how you got here, but they're also largely unaddressed. One of them is a lack of context around why we use specific tooling and like how certain methodologies came to be. And I give talks like this to try to resolve that problem. So if you want to get a hold of me later, you can find me on Twitter at Dixie3Flatline. And I'm always happy to help you if it is within my power. So reach out. Here we go. First, I would like to level set because we have a lot of jargon in cloud technology and DevOps specifically, like a lot of it. And some of these concepts are relatively new, but some of them are considerably older than we like to think of them as. And even worse, sometimes the definitions kind of change over time. And a lot of the documentation we use, it assumes that you already have additional context or that you're proficient in some related tooling or some like predecessor to the thing you're reading about. And that doesn't really make it easy to learn. So today I'm going to teach you about a core concept of DevOps and its history to give you a little bit more context and hopefully make it easier to pick some of this stuff up. So we talk about CI/CD like it's one thing today, but it's two separate and distinct pieces. The CI stands for continuous integration, and the CD can stand for either continuous delivery or continuous deployment. They do mean different things. And I know this sounds like confusing and it's already getting kind of weird, but I promise I will explain that. So practicing continuous integration just means merging all developers' working code base in with the source multiple times a day. If you do this, it requires a series of automated build and unit tests. You've got to ensure none of the proposed changes are going to cause problems later on, but the result is that bugs and integration issues are discovered way earlier in the development process. Ideally, a build is triggered with every single commit, so failures are caught by the developer generally immediately, and then they get corrected right away. This also forces engineers to write code that's more modular, which makes it easier to support later on. So continuous integration has actually been a thing for a long time. It's been around since the early 90s. It hasn't always been called that, and some of the implementation has changed, but the spirit has remained pretty much the same. Merge changes into source in smaller and more frequent increments, test that the project still builds and runs with those changes, and make sure your engineers are all working from the most recent version of the source. If you do this, you won't end up with a ton of merge conflicts or surprise problems when it comes time to actually build. Now, while we may have like started doing this a little bit earlier, the coin was termed and first formally proposed by a man named Grady Booch in 1991 in his book, Object-Oriented Analysis and Design with Applications. If you're in the crowd and you're older and you've been doing this for a long time, you may have read this book. It was great. The Booch method advocated for more frequent use of classes and objects in programming in order just to simplify design. That was the whole goal. His version of continuous integration didn't suggest releasing multiple times a day, though. In 1997, extreme programming became a thing, and it built on the Booch method by advocating for releasing multiple times a day, finally taking that step to doing it repeatedly. And this kind of changed the game, honestly. And I know the name sounds ridiculous now, but it didn't mean extreme in like a 90s X Games, like edgy product marketing, Alienware computer kind of way. It meant taking concepts and paradigms that were already accepted parts of writing and releasing software and then taking them way further, just like do that thing harder, take it to the extreme. So thanks to extreme programming, we now have shorter release cycles. We have extensive code review in the form of pair programming. We have unit testing. We have acceptance testing as standard aspects of writing software. We just do these things. We don't think of it really as extreme programming anymore. And these are all things that make our lives easier. They radically improve quality. From there, more and more methodologies built on the work of their predecessors. We had Scrum and Kanban, all with one goal in mind: make it easier to write clearer, higher quality code and get it to the users faster. Now, in the early days, while we recognized that we needed to be releasing more often, we didn't really have the tools to make that easier. We didn't get the first open source tool to make continuous integration achievable for most people until 2001 with the release of Cruise Control. If you go to Google Images, if you look up old screenshots of this, it looks pretty primitive now, but at the time it was revolutionary. So funny aside, this isn't the actual logo for Cruise Control. I couldn't find a version of their logo with a transparent background. And like, yes, I could have just gotten the logo and dropped it into Photoshop and removed it myself, but that was more work and this is funnier. You see, background transparency is a feature of the PNG image format. And the PNG image format wasn't widely supported by browsers until Internet Explorer 9, which was released in 2011, which was 1 year after the last update to Cruise Control. So that's how old this is. And I know that like it's easy to think, oh, 2011, that wasn't that long ago. It's 2022. It was a long time ago. And people still use this. Cruise Control is actually still in use in production, even though it hasn't been updated since 2011, which is, mildly horrifying, but whatever. Anyway, so Cruise Control was revolutionary at the time of its release. For the first time, we had a system that we could install and stand up ourselves to automate the management of builds, which allowed us to release way more of them. It even integrated with your IDE, if you were using Eclipse, at least, because Cruise Control was Java specific at first. If you were writing like Ruby, for instance, you had to use the Ruby variant of Cruise Control. There wasn't like a language agnostic option. Now, eventually it was overtaken by Jenkins, which is still pretty widely in use today. You've all probably touched it at some point. It supports a ton of different languages. It can be made to do almost anything you want. And it has an enormous community around it. So when you do run into a problem, because you will, you do with almost anything, it's almost certain that whatever problem you're having, somebody else has run into it before and somebody else has documented the solution. It's stable, it's secure, and it's popular. However, Jenkins is kind of starting to show its age now. You have to stand up infrastructure and install it yourself, and somebody has to be responsible for maintaining it. You need babysitters for Jenkins. This is true to an extent even with Jenkins X, their newer cloud native offering, by the way. Enter the cloud. This is kind of where we are now. Rapidly self-hosted, self-managed CI tools like Jenkins or the now defunct Cruise Control are being replaced by cloud services that you don't have to babysit, like Travis or Circle CI or GitHub Actions. They support dozens of languages and in build environments. They know how to deal with cloud native technologies like Docker and Kubernetes. They integrate directly with a wealth of other services to handle deployment or analytics or observability. It's both more flexible and lower maintenance. There is an argument by some that you do lose some security by not being 100% in control of your CI system, but genuinely that comes down to a people issue, because for sure your at-home managed Jenkins server is just as capable of having security flaws as something hosted on the cloud. So for most people, this is a totally acceptable trade-off. And frankly, you could probably give a whole conference talk on that argument there. But that's only the CI. So we need to define the CD. Continuous delivery means what it says on the box. Your software updates are continuously delivered. In concert with continuous integration, this means that you should have the ability to deploy a new build very rapidly because you've automated some quality gates that would otherwise need to be performed manually, like building, testing, vulnerability detection, that kind of stuff. That reduction in manual labor means that you get to release a bunch of small changes rather than one huge update every couple of months. And since you're now making smaller incremental changes, you can also be more confident that your release isn't going to break when you deploy to prod, or that if it does, you're going to have an easier time tracking down what the problem was. Continuous deployment is very similar, but it goes one step further. That deployment step is automated too. In continuous delivery, there is still a manual quality gate involved before an update is out in the wild. Automating that is a pretty controversial step for some people. It requires a lot of trust in your system, a lot of trust in your tests, but personally, I am a big fan of it. For us and for DevOps to be as efficient as possible, we have to reduce human involvement wherever we can. I say this a lot. I probably say this in half the talks I give, but we are really, really bad at repetitive tasks. People get bored, we get distracted, and we're actually pretty slow. If you write good, comprehensive tests and automate everything you can, and then accept that you absolutely are going to deploy a bad update eventually, whether a human is involved in clicking the big green button or not, you'll be much happier. What matters is how quickly you can respond to and correct a bad update. Both continuous delivery and continuous deployment help with that. So, high level, CI/CD is just the term for the marriage of these concepts, and it's an important part of DevOps since automation and efficiency is like all what we're about. One of them doesn't really work in the context of DevOps without the other. It gets you a faster, more reliable release cycle. You can add new features or bug fixes way faster since you know that your engineers are all working from the most recent source. You know that there are unit and integration tests, and you know that it builds. There aren't a bunch of manual steps involved for the engineers or for QA or whoever else you might have managing quality gates. Instead, somebody pushes a code or opens a pull request, and those steps are taken care of by your CI/CD tooling. This opened the doors for more, though. Many of the tools and concepts we now think of as integral to doing DevOps correctly wouldn't be possible without CI/CD there as a backbone. We didn't just get more frequent releases. We also got some things that it's pretty hard to imagine living without now once you use them. We got better metrics. We got better logging. We got observability tools, observability as an actual concept, tracing, a whole host of security tools, and on and on and on. It really gave us a lot. So now that we know what CI/CD is, let's take a look at what software updates actually looked like in practice at various points throughout history, and then some stories about when it could have made a bad situation less catastrophic. May not have prevented it, but it might it might have made things less destructive. So if you're around my age or older, I am 32, you probably remember how much drama used to be involved in software updates. They were huge. They were very infrequent. It was not unusual to wait a year or more for a software update. They took a lot of time to apply. The change logs were massive and unreadable. There was a fairly significant chance that the new version would be like crazy buggy in some way. And it was just generally a really inconvenient experience. Like, it was unpleasant. I used to dread updating anything. If you're younger than me, it might sound kind of wild now, but it really used to be totally normal and expected to go a year or more without seeing a software update. It was a big deal. It was a whole fiasco every time. When Java reduced its release cadence to like every 6 months, people lost their minds over it. Regardless of your age, can you imagine waiting that long for a software update right now? Like, if you're working as an engineer, can you imagine waiting that long to release a single update for whatever product you're supporting? I can't. I can't. I've done it, and I can't imagine going back to that, you know? So in a lot of situations, it wasn't even possible to just download an update. The manufacturer would have to provide you with the update via some kind of physical media, whether that meant floppy disks or CD-ROMs or a USB drive. And this is not that long gone. This is not that far in the past. The last time I had to do this was in 2009, updating the software for the video store I worked at. Literally in 2009, the vendor had to snail mail me a thumb drive. Really, we had internet. You know, we had broadband internet. It was just like a little, couple 100 MB executable, but they had to mail me the drive. They would not email it to me. I asked, and they wouldn't do it. And now, to be fair, this particular application still required a machine with a serial port, which by then was already obsolete, since license authentication was performed by verifying the presence of a physical dongle that only connected via serial. Now, some things actually do still work this way. It is exceedingly rare outside of a handful of industries, but you do still sometimes see this. I don't expect it to last much longer, though. Phones have suffered similar problems with the CD side of things way back in the 90s. For instance, there was not really a way to update the software on your phone, for instance. So if you had a phone and it didn't have Snake and you wanted Snake, there was no just downloading Snake. You had to buy a new phone. Eventually, phones got smarter. We got better at this, but updates still required plugging the phone into your computer and installing some like proprietary application that managed the update for you. And cloud storage wasn't ubiquitous yet. So data transfers when you upgraded to a new phone were also done via a physical cable, either making a backup to your computer from your old phone and then plugging your new phone in and restoring from there. Or there was a point where you could just like plug your iPhone into your Samsung Galaxy and it would do that for you. That one is also not too terribly long dead. The last time I had to do that was when I switched from a Samsung Galaxy to a Google Pixel, which was like 5 or 6 years ago. And now this is something that we don't think about. You switch phones, you log into a couple of accounts, and all of your contacts and photos and apps and whatever else are just there on the new phone. There's some setup time, sure, but it happens pretty seamlessly now. It doesn't require any extra work on your part other than like logging into your iCloud account or logging into your Google account, right? And when an app needs to update on your phone, you don't even notice it anymore. Most of the time, it happens automatically while you're asleep. That's what my phone does. Like, do you know what the version number is of like the Netflix app on your smart TV or the version number of the Twitter app on your phone? Do you remember the last time it updated? Probably not. Some of you, a minority of you, will have ask me for updates enabled on everything on your phone. But generally, the only updates we notice on stuff like phones these days are full operating system updates. My phone asks me when it wants to install a new version of Android, but that's it. So we've gotten much better at this over time, in large part due to the prevalence of cloud computing, but we're still not exactly perfect. So let's look at some real world examples of situations where CI/CD could have prevented a serious problem or at least made it less bad. I'm going to talk about the money angle first. It turns out that not updating frequently and automatically and not having any logging or tracing can actually be really, really expensive, fatally so, it turns out. So in 2012, a bad software update caused a major stock market disruption and tanked the value of a company called Knight Capital. Knight Capital was a trading firm. They specialized in automated transactions on the New York Stock Exchange. And one day, it all kind of came crashing down because you see, they weren't automating their updates or their deployments, and they weren't updating very frequently either. Remember earlier, I said that humans are bad at repetitive tasks, right? Well, we're especially bad at them when we don't get a lot of practice. We're going to make some mistakes. So two things contributed to this disaster. When the engineer who was updating the 8 servers responsible for handling these automated trades was doing his thing, he forgot one of them. Only 7 of the 8 had the new software. They also reused an API endpoint and changed the behavior in the new version. Now, there's situations where it's totally valid to do that, and situations where you should never, ever consider doing that, right? You should change the route. Not worth arguing over in this case, but you can probably see where this is going. When this went into production, it was immediately chaos. Requests to that old server running the old API endpoint wreaked havoc on the share prices of 148 companies. Remember, there's still 7 good machines online at this point. Engineers responded, however, by taking the 7 updated machines offline to roll back the software, which increased the load on the one machine that was never updated to begin with. They had no logging, they had no monitoring, there was no observability in place here at all, they had no alerts. They had to sit there desperately trying to figure out what had happened, losing money minute over minute. In the 45 minutes that this bad update was live, Knight Capital lost $440 million and ultimately went out of business as a result. This was preventable. These servers were all being updated manually, but humans get tired. We get bored. We get distracted. We have bad days. Sometimes you're just not feeling 100%. It's normal. It's natural. And this engineer should not be blamed for this happening. He shouldn't have been put in a position for this to happen, right? There should have been processes and tooling in place to protect the engineers from being put in a position where this screw up could occur. If the process had been automated, this might not have happened at all. But for me, the most compelling argument in favor of spending the time and effort on automation is security. This is also probably the most visceral example I have. It's certainly the one that is the most likely to have touched several people listening to this talk. So CI/CD enables you to update your software much more quickly, right? And this translates to being less vulnerable to known issues because you can react more quickly if a breach does occur. And if a breach hasn't occurred yet and you know about a vulnerability, it's easier to push a patch, right? This is a story that most of you are probably familiar with. though you might not be aware of exactly how it went down. In September of 2017, Equifax announced that a breach had occurred between May and July of that year. The first month is relevant, May. Okay. So for those of you who are not familiar with this breach, the names, addresses, birth dates, driver's license numbers, social security numbers, everything of just shy of 149 million Americans had been stolen. The hackers had exploited CVE 2017-5638, which was a vulnerability in a very commonly used web framework called Apache Struts. And so talking about exactly how this vulnerability works is out of scope for this talk, but the gist is that it would allow an attacker to remotely execute commands with whatever authority the web server had. This was not a vulnerability that flew under the radar, to be clear. Even before the breach, this CVE was big news in the security world. It was classed as a critical vulnerability. It was given a CVE score of 10, something that absolutely had to be taken seriously and corrected immediately. The vulnerability was disclosed and published in March, months before Equifax would be breached in May. So once they discovered the breach, this is where it gets uglier. It took them 2 full months to find and upgrade all usages of the vulnerable version of Struts. Hackers had remained in the system undetected for months at this point. Lawsuits were filed, resulting in a $575 million settlement with the FTC, as well as payments and credit monitoring for those affected. However, unfortunately for 149 million of us, the number of people affected was so large that after attorney's fees, most of us got nothing but a lifetime of being paranoid about our credit. This was caused by a lack of vulnerability detection, but it was exacerbated by an inability to update quickly and a lack of knowledge of their own systems. Exactly the kind of thing that robust CI/CD is there to help mitigate. So, to wrap things up, CI/CD is a combination of a methodology and tooling with the goal of increasing your speed and efficiency as a developer by automating tasks like building and testing and deploying so that you can do all of those things more often and think about them less. We're all trying to think less here. The benefit to you is more frequent software releases, earlier detection of bugs, and bad releases making it into the wild less often. It's been around for a long time. Longer than we like to think. It feels very new, right? Because DevOps has only been around for a decade. So CI/CD feels super, super fresh, right? But it's not, it's old. It's just changed a lot over the years. And it's resulted in a whole bunch of tooling that we couldn't have without it. This has taken us from waiting a year or more for a big unwieldy update to not noticing or caring when an app on our phone updates overnight. It's pretty incredible. So I hope I've helped you understand the history of CID and CI/CD and some context around why things are the way they are, and how it's changed since Booch first coined the term. It's really grown a lot. I will be around for questions for a little bit, but if I can't get to you, feel free to get in touch on Twitter at Dixie3Flatline or shoot me an email at cat@palumi.com. But I will warn you that I am not great at replying to emails with any level of urgency, as PJ can attest. I get a lot of emails. Bye.